Alright, so the lesson today is about dividing polynomials. We're going to use both synthetic division and long division. So your central question is, why do we write the remainder as a fraction with the divisor as the denominator? So we're looking specifically, why do we write that remainder as a fraction? This is your prove it today. You'll be able to take some sort of polynomial and divide it by another polynomial using either synthetic or long division. Alright, so we're going to go back to 4th grade, and we're going to revisit long division with just regular numbers. So go ahead and pause the video and see if you remember how to do this. Alright, so hopefully you were able to get 726, and then it had a remainder of 7, so we said it's actually 7 divided by 8, because that's what we're doing, and a fraction bar means divide. So if you recall, we take this 8 and we say, alright, how can I make 8 look like 58? Or what's the biggest number that will go into 58? And we realize that 56 is the answer. So 7 times 8 is 56. And then we do the opposite. So it was a positive 56. So I subtract. And that leaves me with 2. And then I bring down the 1. So how many times does 8 go into 21? Well, it goes in twice. So 2 times 8 is 16. And then I do the opposite, and I'm left with 5. And then I bring down this 5, and 8 goes into 55 6 times. So that gives me the 48. And when I subtract, I have 7. Well, 8 can't go into 7, so it's left as a fraction, 7 divided by 8. Alright, so in order to use long division, I need to rewrite it into that format that we're a little more used to. And I need to make sure 2 things. 1, that it's in standard form, so that all of the degrees are descending. And 2, that there's a placeholder for every exponent. So if I have something to the 4th power, I have to have to the 3rd, to the 2nd, to the 1st, and then to the 0. And if I don't have those, then I need to put a 0 in as a placeholder. And we'll look at some examples like that. But let's start with this first example. I'm going to rewrite it. So I've put my divisor here and what's being divided into here. And so I'm going to start the process, and I'm going to ask myself the question, what do I need to multiply to make it look like the number that I'm looking at? So I'm going to start, I'm always going to look at this first, the leading coefficient. And I'm going to say, what do I need to multiply v by to make it look like v to the 3rd? So the answer to that is v squared, because v squared times v is v to the 3rd, which is what I want. But I'm not just multiplying v by v squared, I'm also multiplying that plus 7. So essentially I'm distributing. So 7 times v squared is a positive 7v squared. And just like when we were dividing with long division in just numbers, we're going to do the opposite. So this v to the 3rd is positive, so it becomes negative, and this 7v squared is positive, so it becomes negative. And then we just combine like terms. So v to the 3rd minus v to the 3rd cancels, which is what I wanted, and then 9v squared minus 7v squared is 2v squared. Alright, and then I'm going to bring down, just like we did in long division, that plus 7v is going to come down. So now, again, I'm going to look at, what do I need to multiply v by to make it look like 2v squared? So that's going to be a positive 2v. And so then I distribute, and then I combine. So 2v times v is 2v squared, and 2v times 7 is a positive 14v. And just like we did with long division, I'm going to do the opposite. So 2v squared minus 2v squared cancels, and then 7v minus 14v is going to be a negative 7v. And then I'm going to bring down that minus 56. And I'm going to go through the process again. What do I need to multiply v by to make it look like negative 7v? So I would need to multiply it by negative 7. Because the coefficient of the v is a 1, and so I want it to be negative 7, so I have to multiply by minus 7, and then I distribute. So negative 7 times v is negative 7v, which is what I wanted, and negative 7 times positive 7 is negative 49. And then just like we did, we do the opposite. So these are both negative, so they become positive. So negative 7v plus 7v cancels, and negative 56 plus 49 is a negative 7. Well, there is nothing that I can multiply v by and get negative 7. Because if I multiply anything by v, it's going to have that v in it, and I need no coefficient or no variable. So this just becomes my remainder, and I write it just like we did in the regular division. It'll be minus 7 because it's negative over v plus 7 as the denominator. And the reason that we put it as a denominator is because essentially a fraction bar means divide. So what this is saying is take the negative 7, and we're still dividing it by 7v plus 7. We just can't get something nice and easy. So that is my final answer right here. That is the solution to v to the third plus 9v squared plus 7v minus 56 divided by v plus 7. So go ahead and write down any questions or points of confusion that you have, and we'll talk about it tomorrow. Alright, so we're going to do this exact same problem, but we're going to use what's called synthetic division. I prefer long division, and I think it's just because I didn't have a lot of exposure to synthetic division, but you can choose whichever method you would like for the sake of our class. But I'm going to walk you through that process. So for some people, synthetic division makes a lot more sense. So the thing with synthetic division is we only use the coefficients we don't use any of the variables. So the first step is we're just going to write the coefficients of what we are dividing, and we have to be very careful that we have those placeholders like we talked about in the previous one. So if I skip an exponent or a power, I have to put a 0 in. And then we always want to make sure it's in descending order or standard form. So I'm going to go ahead and I'm going to go through and write just the coefficients of the first piece. And so I'm going to have a 1, I have a 9, I have a 7, and I have a negative 56. So I got those from right here. And then what I'm going to divide into, it's a little tricky, but essentially I'm going to think about what would v have to be to make this 0. And so we're kind of doing like those restricted values that we've talked about. So what goes in this box right here is a negative 7, because what would v have to be? I essentially set that equal to 0 and solve, and so that's where I get the negative 7. Alright, so once I do that, the first step is that this leading coefficient just comes straight down. And so all we simply do now is we do negative 7 times 1, and we get negative 7, and then we just combine those. So 9 minus 7 is 2, and then we do negative 7 times 2 is negative 14, and then 7 minus 14 is negative 7, and then we do negative 7 times negative 7, which is negative 49. I'm sorry, positive 49, and negative 56 plus 49 is negative 7. And so this number is my remainder, and if you notice, these are familiar numbers. They're just like the problem that we did. And we put our variables back in, except for we always do it one less than the original power. So this becomes v squared. This is v, and then that minus 7 is just my constant. So my final answer is really v squared, and this is a positive 2v, minus 7, and then minus 7 over what was I originally dividing, my original divisor, and that's my final answer. So synthetic division, it can be easier. It's pretty much the same process, it just looks a little bit different. So you can choose what you prefer. So go ahead and write down any questions or points of confusion that you have, and we'll talk about it tomorrow. So for this example, I would like you to actually do both divisions. So do long division and synthetic division. So if you feel like you've got the hang of it, go ahead and pause the video and solve it out. If you are a little lost or confused still, that's fine. I will keep walking through the process. Alright, so I'm going to go ahead and do long division on the left-hand side, and then we'll do synthetic division on the right. So I'm going to rewrite the problem. This is my divisor, and it's going into k to the third is my largest power. So then I have to go descending, k squared plus 13k, and I don't have a constant, but I need a placeholder for it, so I'm just going to put plus 0. So what do I need to multiply k by to make it look like k to the third? Well, that would be k to the second. So k to the second times k is k to the third, and k to the second times negative 2 is negative 2k squared. And then I do the opposite. So if it was positive, it becomes negative, and if it was negative, it becomes positive. K to the third minus k to the third cancels, which is what I wanted. And then negative 11k squared plus 2k squared is negative 9k squared. And then I bring down my plus 13k. All right, what do I have to multiply k by to get negative 9k squared? Well, I would need to multiply by a negative 9k. So now I'm going to distribute that negative 9k to both of those pieces. So negative 9k times k is negative 9k squared, which is what we wanted. And then negative 9k times negative 2 is a positive 18k. And when I go to combine, I do the opposite. So if it was positive, it becomes negative, and if it was negative, it becomes positive. So negative 9k squared plus 9k squared cancels, and then 13k minus 18k gives me negative 5k, and then I'm going to bring down that plus 0. So what do I need to multiply k by to get negative 5k? That's going to be minus 5. So negative 5 times k is negative 5k. And then negative 5 times negative 2 is a positive 10. And then I do the opposite, so add and subtract. And so 0 minus 10 is negative 10, and there's nothing I can multiply k by to make negative 10, so that just becomes my remainder. Minus 10 over k minus 2. And that should be my answer. So let's go ahead and do synthetic division on the other side to prove that is the answer. Alright, so for synthetic division, we want to use just the coefficients and make sure that the expression is in standard form and that there are placeholders. So k to the third is going to be 1, negative 11, 13, and then I'm going to put that 0 on the end because I need that placeholder for k to the 0 power, essentially. And so what would the denominator have to look like if that were 0? And so k minus 2 equals 0 would put a positive 2 here. So we bring down the first coefficient, and then we just start multiplying. So 2 times 1 is 2. Negative 11 plus 2 is negative 9. 2 times negative 9 is negative 18. 13 minus 18 is negative 5. 2 times negative 5 is negative 10. 0 minus 10 is negative 10, and that becomes my remainder. So then I go back and I put my variables in, but they go one less than the highest power. So this becomes squared k and then to the power of 0 essentially. And so if you notice, I did it correctly because I have k squared minus 9k minus 5 and then minus 10 over the divisor. So k squared minus 9k minus 5 and then minus 10 over k minus 2 is my final answer. So go ahead and write down any questions or points of confusion that you might have, either the long division or the synthetic division. Alright, I'd like you to pause the video and try number 3, both the long division and synthetic division on your own. So hopefully you were able to get 10x squared plus 8x plus 4 using both the long division and the synthetic division. So if you got that, you can go ahead and move on to the next example. If you didn't, then go ahead and pause the video and see if you can look through my steps. Please take note of any points of confusion or questions you might have about one of my steps. Alright, so for example 4, go ahead and pause the video and try it on your own. Alright, so hopefully you ended up with 9r squared plus r minus 1 minus 3 over r plus 10. If you got that, you can go ahead and move on to example 5. If you didn't, pause the video, look through my work, and write down any questions about places that were confusing. Alright, so for example 5, go ahead and pause the video and work through this problem on your own. Alright, so hopefully when you worked it out, you ended up with n squared plus 6n minus 10 plus 6 over n minus 6. And something that might have tripped some people up is if you notice in the original problem it goes from n to the third to n to the first. So I have to have that placeholder for the n to the second. Alright, if you got that answer right, then go ahead and move on to example 6. If you didn't, look through my work and take note of any questions or points of confusion that you have, and we can talk about it tomorrow. Alright, we have 2 more examples left, so go ahead and pause the video and work through example 6, and let's see if you got it. Alright, so hopefully when you solved it out, you ended up with 8x squared plus 6x plus 8 minus 5 over x minus 6. If you got that, you can go ahead to the last problem. If you didn't, then pause the video and look through my work and see if you can find where you went astray, and make note of any questions or points of confusion that you might have. Alright, this is our final example. Go ahead and pause the video and work it out on your own. Alright, so on this final example, you should have ended up with x squared minus 3x minus 6, whether you did it by long division or synthetic division. So go ahead and if you got the right answer, then keep moving through the video. If not, pause it and look through my work and see if you can find your points of confusion or any questions you might have. Alright, in your notes, I do want you to write down what are 3 errors you think students tend to make when dividing polynomials. I know for me, one of the things I see a lot of is especially if they need that placeholder, they forget to put in a 0. So what are some other errors you think students tend to make? Do you have any questions? And what do you need to remember about dividing polynomials? So write that be sure to statement for yourself. And don't forget your summary. Alright, I'll see you tomorrow.